There we go, recording in progress. Today we're going to be talking about enzymes, one of the most important kind of function kind of groups inside of the human body. So I'm sure you guys have all heard of the word enzymes. Does anyone know any examples of enzymes per se? It's okay if you guys don't. I'm sure you guys have heard of people who are lactose intolerant. That means their bodies can't break down the lactose, partially because the enzyme lactase is either not present or not functioning in their body. And so that's kind of a common example of an enzyme. But just to start off with the basics, the majority of enzymes, they are proteins. And so they're made through protein synthesis. There's a video on protein synthesis on the YouTube. And the job of enzymes is to catalyze chemical reactions in cells. And these can have a wide variety of functions, sorry. They are present in the digestive system. They are present in the mouth, where they can help break down certain carbohydrates, and they are even present in your saliva. So when you chew in your mouth, enzymes are working in your mouth to break down what you chew. They are also very active in your digestive system, in your bowels, to break down certain proteins, certain molecules, certain carbohydrates. They're also very crucial in DNA replication. Enzymes are used to unzip the double-stranded DNA helix, which is, very important, because if you don't unzip it, you can't replicate the DNA. And they're also very present in the liver. Does anyone know what the liver does? So the liver is an organ. It sits pretty close to the stomach. And the liver's job is to clean out the human body. So if you drink some alcohol, which you guys definitely shouldn't do, you guys are still underage, the liver will actually work to clean the alcohol out of your body. That's why if you drink too much alcohol, you get liver failure. And so that's why you don't drink too much alcohol. But the enzymes in the liver are in charge of breaking down toxins inside the human body and kind of expelling them out. So that's why they're present in the liver. Oh, that's not supposed to happen. Okay, there we go. Yep. The really cool thing about enzymes is that they are reusable. Think of like a reusable water bottle, for example. You can use it over and over and over again, like this kind of glass water cup I have here. I can use it to hold water over and over again. Same thing with enzymes. The human body can use enzymes to break down certain substances over and over and over again. And this last point is that they are very temperature specific, which means that enzymes only like certain temperatures. They're actually very picky. It's like if one of you is a picky eater or something. There's nothing wrong with picky eating. But enzymes are just as picky about their temperature as you are about your food, if you are a picky eater. And so let's talk about the little, oh, that's not supposed to happen. Let's talk about the little pictures I've included here. This one is one that you guys might not have seen just yet, but once you guys get to high school, I promise you, you will see this chart over and over and over again. This is kind of an energy readout graph. And basically, what's happening here is when I mentioned that enzymes catalyze chemical reactions, all it means is that enzymes make it easier for the chemical reaction to run. And so without enzymes, a lot of reactions in our bodies don't run as well, or they run much slower. And basically, if you see without the enzyme, it takes a lot more energy. And with the enzyme, it takes a lot less. The spike is much smaller than this big red spike. If you can see the blue line, it spikes only a little bit, and the red line, it spikes a lot. And this figure describes how enzymes actually activate with their like chosen substrate. The substrate is what we refer to as whatever the enzyme is acting upon. So we can see that the enzyme binds to the substrate in something we call this active site right here. If I can go ahead and draw here. Here we go. So if we kind of circle this active site right here, you can see where the substrate actually binds into the enzyme, and the enzyme actually breaks apart this substrate. So you get one product and you get two products here. So can everyone see how this kind of breaks apart and the enzyme catalyzes the breaking apart of this substrate? Okay, that should be relatively apparent. And oh my, that's not supposed to happen. Okay, hold on. Let me clear these annotations quickly. Annotate, clear. Okay, great. And this last figure simply describes what I said earlier about how enzymes only work at certain temperatures. What happens is enzymes have an optimum temperature. It's like putting a human in an ice bath down here. I mean, humans don't like to be super cold, and nor do they like to be super hot. And so just around 40 degrees Celsius is where enzymes work best. The human body is close to this temperature, I believe. I think the value is around 38 to 39. It's in the high 30s, close to 40, and so somewhere around this temperature. What happens is, as the temperature increases, enzymes can actually denature. And denature simply means that the enzymes, they change shape, they become all wonky looking, and they just don't work as well. And so basically, if you overheat the human body, then enzymes don't work as well. That's why we don't like heating up the body too much. Optimum is also an internet company. I didn't know that. I wouldn't have known that for the life of me. But I mean, the more you know.
I have to leave at 1:30.
At 1:30?
Yeah.
Okay, you must be in California then.
Yeah.
Okay, yeah. So I'm 3 hours ahead on the East Coast. It's like 4:10 for me right now. It's probably 1:10 for you right now, right, Colby?
Yeah.
Yeah, okay. Okay. I'll try to make it quick then. Okay, let's talk about enzyme models. Okay, let me move the little thing. Okay, great. So there are two kinds of enzyme models that we refer to when we talk about how enzymes work. And let me get a sip of water. My mouth's getting dry.
Wait,
So
do the enzymes do they how do like how do they cling on to the substrate? Because the substrate has different shapes.
yes, yes. So that's what these models actually talk about. So if you will let me, Colby, let me talk about the enzyme models. And if you still have a question, then you can ask. Does that sound okay?
Yeah.
Okay, great. So the lock and the key model is the earlier kind of model that we work with. This is kind of like the father of like enzyme models. He's kind of the first one. So the lock and the key model says that the active site of the enzyme complements the substrate, meaning they're kind of like, if you think about Lego bricks and how Lego bricks fit together perfectly, that's how the substrate fits into the active site of the enzyme perfectly. If we go over here and let me annotate again on the screen, we can actually see that this kind of substrate will take in, will go into the active site in this kind of perfect shape. So the active site is actually molded into the shape of the substrate, which means that the active site can only take this one specific substrate, and it kind of binds in, whether through hydrogen bonds or simply any kind of molecule-molecule interaction. But what happens is, basically, the active site has to be in the shape of the substrate. And so that's how they match together. I'm trying to think of a better analogy. I
Wait.
mean, the lock and key itself is kind of a very good analogy, actually, because one lock fits to one key, right? You can only use this key to open this lock. If you try a different key, it doesn't work. That's the same with enzyme and substrates. Let's say the enzyme is a lock and the substrate is the key. Only this substrate can fit to this enzyme, and only like these two substrates and enzymes can produce one of these enzyme substrate complexes. Does that make sense, Colby?
Wait, so basically the enzymes are like living shapeshifters, right?
Yeah, kind of. Actually, yes, that is actually a really good assessment because over time, science is always evolving, right? So over time, we actually moved away from this kind of lock and key model, and we go to the induced fit model, which says that the active site of the enzyme, it doesn't necessarily have to perfectly fit the substrate, but as the substrate comes in, the active site in the induced fit model, the substrate actually changes around the shape of the active site, which means that the active site can actually change shape and it can fit itself to the substrate. And so if we look at this figure here, we can see that the substrate, let me go to my annotation tool. The substrate right here, it's a different shape than the enzyme active site, which is out here, right? You can see how the substrate is basically a rectangle, and the enzyme active site is just kind of um, I don't know how to describe it, but it's clearly not a rectangle. And it enters this kind of transition state where the active site actually turns into the shape of the substrate. And we can see that whether or not it's a rectangle or this kind of 1, 2, 3, 4, 5, this pentagon here, it doesn't really matter what the shape of the substrate is. It only matters that the active site of the enzyme is able to kind of mold itself around the substrate. And then, of course, we go to the product stage and the enzyme returns to its normal shape. And so, yes, these guys, they're kind of little evolving, they're kind of, they're kind of little evolving molecules. So yes, Colby, that is correct. Any more questions?
No.
Okay, great. And so the thing to remember about the lock and the key and the induced fit and how they compare to each other is that the lock and key, it's very specific. This substrate goes to this enzyme and that's it. With the induced fit, you get a little bit more variety per se. The active site is a little more versatile. It's more able to adapt to whatever substrate wants to bind to its active site. And this active site, of course, it undergoes change or physical change to improve the binding of the substrate to the enzyme. Okay, let's talk about inhibition, and then we will call it wraps on the PowerPoint, and then we will I just have a quick couple questions for you guys, and then we will move to the book. It's actually just one question, and it'll be quick. Let's talk about inhibition. So inhibition is one of the main issues that enzymes can face, and it's actually quite a big issue. Let me clear all these drawings quickly. There we go, all cleared. Okay, so there are two main kinds of inhibition, and everyone knows what inhibition means, right?
Not really.
Okay. Not really. Okay, fine. Inhibition is kind of a method of blocking. So I can, let's say that, I don't know, Derek wants to buy a book and I prevent Derek from buying this book. I'm inhibiting Derek from buying this book. That's inhibition. I'm basically saying, Derek, you can't buy this book because I'm inhibiting you from buying this book. It's a block. Does that make sense now?
Yeah.
Okay, great. So there are two main kinds of inhibition. The first one are competitive inhibitors. Basically, competitive inhibitors, they block the active site. So if we look at this kind of first figure that I'm going to annotate on, figure A right here, we can see that the yellow inhibitor right here has actually blocked the enzyme active site, which means that the red substrate here, it can't bind to this active site. That's a no-no because this inhibitor is blocking the active site. So that's competitive inhibition. This is the most kind of direct, I'm going to block the active site and you can't get in now. That's competitive inhibition. And then we have non-competitive inhibition. Basically, this one is a little less direct. What happens here is the inhibitor, depicted in yellow again, actually binds to the enzyme in a different site. It doesn't necessarily have to be the active site, but the inhibitor binds to the enzyme, and what happens is it denatures the shape of the active site. The active site actually does not retain its shape anymore. And so the substrate, it can't bind to the denatured active site. That's a no-no as well. And so we can see that the competitive inhibition directly blocks the substrate, and the non-competitive inhibition changes the shape of the active site. We call this competitive because the inhibitor is directly competing with the substrate for this active site. And we call this non-competitive inhibition because this inhibitor is not necessarily competing for the active site. It's not binding to the active site, but it's still blocking the substrate from entering that active site and being able to bind with the enzyme and form the enzyme substrate complex. And so those are the two main kinds of inhibition. Does anyone have any questions?
Yeah, so the inhibitor is another like piece of substrate, right? Like
It can be another substrate. It can be a protein, for example. It can be, there are many kinds of inhibitors. The whole point of the inhibitor is that it is just not the substrate and it is blocking the substrate.
so if it's like a protein that accidentally like wanders into the active site, then what does the enzyme do? Does it like still break it?
The enzyme can try to break it up. It can try to catalyze a reaction. Most of the time, what happens is if an inhibitor gets in there, it can be, I forget the name exactly. I think I have it pulled up. Let me see. Ah, yes. Okay. It can be an irreversible inhibitor, which basically means the inhibitor stays in there and the enzyme can't do anything about it. And the enzyme is kind of just nullified. It's trash now. It can't kick out the inhibitor and it can't take any more substrate. So what happens is it kind of just gets broken down by the body eventually. But if an irreversible inhibitor binds in here, the enzyme, it's kind of done for. There's not much the enzyme can do anymore. Is that okay?
Wait, what if an enzyme accidentally goes into another enzyme?
Okay, interesting question. What happens if an enzyme goes into another enzyme? Um, Usually enzymes, they might bump into each other in the human body, but enzymes definitely won't stick to the active sites of other enzymes. These inhibitors, they have special ways of accidentally sticking to these enzymes or purposefully sticking to these enzymes, but enzymes can't bind to the active sites of other enzymes. Only substrates and inhibitors can bind to the active sites of enzymes. I don't think I've ever heard of an enzyme binding to the active site of another enzyme. Is that okay?
Okay.
Okay, great. Any more questions, anybody? Feel free to drop questions in the chat as well if any of you want anything cleared up. And also, if you guys ask like really detailed questions, I might not know, to be honest. I've had questions like that where, I mean, I didn't know the answer.
Wait,
What's up?
can I see like the how the enzyme looks like in real life, like when it's like molding it, the substrate?
Yeah, so actually, oh no, that's Launchpad. Let's go to Google and let me find a
I
photo.
just came.
Okay. Um, who is it? Is it Daniel?
Yeah.
Okay. Daniel, the recording will be posted on YouTube. So feel free to go on there and take a look after. let me find a kind of artist's rendering of, okay, great. Let me share my Google screen now. Stop share here. Share screen, Google. Okay, so this is actually an artist's rendering of an enzyme, but this orange kind of blobby thing is what we call the enzyme, and this blue thing is the substrate. And you can see the substrate has kind of bound onto the enzyme at the active site. So this is kind of an artist's depiction of an enzyme substrate complex. Is that okay, Colby?
Wait, Lawrence, what are we talking about?
We're discussing enzymes, Daniel. You can stay after class and I will give you the spiel again about enzymes. Okay, does that sound okay, Daniel?
Okay.
Okay, great. And was that photo okay with you, Colby?
Yeah.
Okay. This is another interesting photo. It looks like maybe we have two substrates bound to this enzyme, so that's interesting. This is likely an enzyme with its active site open. So you can see if a substrate kind of meanders on into here, binds to the active site of this enzyme. And I think we have another good photo right here of the enzyme and the yellow substrate bound onto the enzyme here. Okay, but hopefully that answers your question, Colby. And okay, if nobody has any other questions other than Daniel, you can stay after class and we will discuss. I will stop the actual like class part of the class if nobody has any questions, and then we will go to the booklet. But I wanted to ask you guys, because you guys are kind of the the boss when it comes to the fun activities that we do after the class. I don't know much of like the games that you guys play. So if you guys have any suggestions, or if you guys want to move away from the booklet and maybe go back to Kahoot or back to some other game that you guys know, I'm happy to listen to suggestions. I've looked online and it does look like Bookit is the kind of the one that I think would be most interesting for you guys. But if you guys don't agree with that, feel free to let me know and I'll look into other options. Does that sound okay with you guys?
What is Bookit?
Yeah, okay. So I think okay, so Bookit is basically it's like Kahoot, but more fun for you guys, I think. Does any of you guys do any of you guys want to answer John's question about what is Bookit?
Look it is like Kahoot, but
Like more like stuff. Like that makes it
it's
cool.
like look it it's lookit.com.
Yes.
Just read the thingamajig under all the stuff.
Yeah. Okay. Here, John, it will make more sense when you actually play. So I think probably playing will be better than one of us explaining it. So I'm just gonna send a link in the chat, and you guys, I will send a join code as well in a second. And somebody suggested Gimkit. Have you guys heard of Gimkit?
Oh yeah, I have.
Do you guys like Gimkit?
Wait.
I don't really like it. I think Book's better because like the imposter game is not that like.
Wait, what's Gimkit?
I don't know what Gimkit is. That's why I'm asking you guys.
Never heard of it.
Okay. Well,
You might.
Look, Rush, please.
okay, sure. I mean, we can do Book Rush and we can do a bunch of other ones, guys.
Oh,
There's-
look, Rush.
Because I have to leave soon.
Yo,
Yes, okay, yes. People do have to leave soon, so we will play a Book Rush quickly, okay?
look, it got an update.
It did?
I like it.
Yeah, the Lookit got an update. I just noticed. Oh,
Okay, guys, it is the same as Bookit except more game modes. Okay, well, I will check out Gimkit and I'll probably do the next class on Gimkit. I will also send I'll also send the game code in the chat if you
I'm gonna
guys want
see
to
what
join.
GameKit is.
I really don't know what GameKit is. I was just told that it is the same as Book It, but more game mode. So, I mean, I suppose we will try it next class, and if you guys like it, then we will continue with GameKit. And
Oh,
we might even be able to switch off between GameKit and Book It. So it might be fun for you guys.
oh, it's
Can you log in?
Yep.
GameKit
Wait, can you log in? Yeah.
is GameKit is Book It, but it's more like realistic. It's so realistic that it's not realistic.
Bro,
I mean, we will try the GameKit. Okay, I'm always open to suggestions. And if you guys don't like it, well then we'll return to Book It.
this guy loves astronaut.
Does
Wait,
does
what-
okay?
what
Does
game-
anyone else want to join who hasn't already joined?
Oh my god.
See,
Hey, yeah.
it doesn't let me sign in.
Okay. Uh-oh.
Wait.
Okay.
Lawrence,
Yes. What's up?
what does it feel like to be in college?
What is it? Sorry. What does it feel like to be in what? What does it feel like to be in what now?
College.
Oh, I am. Do I look like I'm in college?
You said you were going to college, right?
No. I'm next year. I'm going to college. I'm in my senior year of high school. Oh my god.
Oh,
Something.
No.
The meeting
I'm in my
is ending.
senior year of high school.
The meeting is ending in like 9 minutes. So.
Yeah, I know.
I have to go in 1 minute.
Okay, well, we will start the book it.
No. Good.
click play the goal.
Wait, is it 1 minute?
So you guys just answer the questions and protect
Yay!
yourself. That's all I
That's
do.
boring.
I've never actually played, so this is all you guys. Help each other out if y'all have questions.
Guys, defense champion.
All right, we have the squad, we have the pretty fishies, and we have the party penguins. Oh
We're
no!
literally dying because you guys are not.
Wait, party penguins is already struggling. It's okay. I believe in you guys to make it come back.
These guys have no defense.
Wow, somebody just said you look like you're 30 years old.
I have to go now.
Okay, bye Colby. Bye-bye. Enjoy your week, okay, Colby?
I do not like this game.
Got it right.
Okay, defend. Okay, defending
You
is
just
the
said I look
number one
30.
priority.
Oh my.
Party penguins. Oh no.
Do I look 30 or 30?
Pretty fishies should gain some shield.
But how are these guys so bad?
Oh my.
Defending
Okay.
is the number one
Oh my. The squad is running away with it. Come on, guys. Penguins, fishies, pick it up.
Oh, gain the shield.
and blocks.
So guys, just shield. Just steal. I'm not even playing. Just steal. Bro, guys, just take all. Just get all the shields you have.
Let's go, I got the book.
Guys, destroy the shields.
Okay,
Defending
is the number one priority.
Oh my.
Nobody's doing anything, so I'm quitting.
Maybe I should
What?
have
There's
like
no
shuffled
valid
the team.
targets,
I
so
didn't
we
know
only
that
just
the team
one?
was
We got one team, guys.
Oh, the penguins. Quick. Oh, the fish.
No, let's go get a free book. It's stupid though.
Guys, keep on going, guys. Protect your.
Get the shield. Get
Oh,
the
who's
shield.
yelling?
Well, the fishies have two, and the penguins have one.
Hey, yo, chill, guys.
Oh
No,
my.
no potty words.
Oh my, there are
Just
there's
get
so
the
many.
shield.
They have 15.
Bro, we are so good that nobody is even here.
Just
Oh
take
my.
the shields.
Oh my.
Shields are number.
Okay.
No, we're gonna lose our shield.
Okay, they got one shield.
Killed the squad. Unless you're just.
All right, guys. I think I'm gonna end this one
Yeah,
now
yeah.
because it looks like it's really unfair.
Oh yeah, I don't think.
So I'm gonna go ahead and just end this one. Oh,
anybody have
at
a
least they got
chance.
one.
That's not gonna do anything. That game was great.
He wins.
Okay.
Easy done.
Yeah. Okay, that wasn't even remotely close to being fair. Okay. let's host one more while we still have
Were we
6 minutes.
supposed? What were we supposed to do? Were we just supposed to get them correct, or?
I
Yeah.
think we're supposed to try and get as many books as humanly possible.
Factory.
Factory is fun, but I don't know.
Factory.
Yep, sure.
Factory.
All right, I'm gonna set it to 5 minutes. And you guys are gonna have to join really fast because we don't necessarily have 5 minutes. Actually, I might just end it a bit early. It's fine.
But what? How's someone out here?
If you guys were to guess my age, well, how old do you think you how old do you think I look?
18. 17.
Lyndon, be quiet. You're my brother. You know my age.
600.
600. Oh my god, you guys are brutal.
You seem pretty old.
You are
I think I heard a 30 in there too.
19.
93.
93.
Negative 38.
19.
Bro, it's
Oh my
less
God.
than 19. It's like negative.
Guys, I'm 17, okay? I don't
Oh,
look
let's go. I
20,
know it. I
don't
said
look
negative
30.
17.
I'm 17, guys. Everyone will.
Man, I thought you were 600.
Oh my gosh.
Oh,
I was pretty close.
I knew.
Excuse me, you're like 100. You're like
I
500.
think we should
You're
start
like
it.
negatives. You're like pi.
oh.
Oh no, I don't need the tutorial.
Yes.
I'll just eat reduces the
I can't believe you
frustration.
guys said I looked 30.
This is
I hate this game though.
It blocks. This is a
So guys,
easy.
Yay.
Tiger, I don't have time to do
Lawrence,
What's up? What's up?
When the temperatures get too hot.
Lawrence,
Squirrel.
What's up? What's up? Yes.
Which one's the fastest production? Yep, that's faster.
I keep on hearing my name,
Yes.
but I don't hear a question or a statement behind it.
that's because everyone's talking over.
It changes the shape.
Everyone's talking.
Blocks.
Are you guys making fun of my age again? I don't know what's happening.
No, Lawrence
It produces.
Oh, I'm 17. Yes, I'm 17.
Oh, I was close.
Stop
You guys are hard.
Yeah.
No, I chose the wrong accent.
Bro, stop talking.
Why don't seagulls?
I really don't care what you call a fake noodle.
Bagels.
Oh my god, what do you call it?
The nature.
It's
I'll do this.
like somebody's having a rage fit.
Yeah.
What the heck?
Oh, this actually helps my eyesight.
But who did this? Okay, actually, we can see who did it at the top.
How does a competitive inhabitor work?
Inhibitor.
Be quiet.
Sounds like somebody's dying.
I just realized I
No, it just blocks. Find
Give
out
me the
what
money.
they do. What's the function? It breaks down.
God, what are some of the effects?
Royale.
Yes, sir.
Walk 18 natures. It's the natures.
This guy sounds like a good idea.
Yes.
Guys, stop talking.
Actually, we did win
What
the
is
first.
happening? What is
Yeah.
happening?
Okay.
Oh geez. Oh, it's nighttime.
That was a bad idea. I'm just saying.
How is it a competitive?
How does a non-competitive
You know,
work?
I'm so bad at this game.
You know,
Gee,
I'm not
why am I so bad?
playing.
Okay, what?
Damn.
Oh, it's daytime again. Oh boy.
So
Um,
guys,
Whoever
Oh, are you
is
kidding me?
leading, and we have Lilian in second, Derek in third. Pretty close game actually between 1 and 2. Liliana could take it. I don't know. Oh, and Liliana does take it. Wow. With 4.5. I don't know. Was that double? Oh my.
But who's in first?
Liliana is in first right now. Derek is in second.
I cut.
Change here.
This looks pretty easy.
Derek takes second back. Well done.
Oh, Liliana just got 4.8.
You what? Is he like in
Oh,
an
Derek
older
takes
group or, like,
first.
oh no.
Derek is
Oh,
first.
wait, what
Let's
just happened?
go. Wait,
That's a glitch.
Thing.
The-
That activated the micro glitch.
second place is worse than first place.
Micro glitch.
Oh, why is it so big?
It's the
Oh, let's go. I got king.
Oh my
Easy,
lord,
easy,
what is happening?
easy win.
Okay,
Easy
I
dub.
know the timer says 1 minute 20 seconds, but you guys actually have 1 minute and 6 seconds. Actually,
What?
no, you guys have 4 seconds. Just kidding.
4
Actually, I'll give you
seconds.
guys 10 more seconds. I don't think anyone is gonna catch the lead.
Jeez, why does my guy take like 10 years?
Where does some of the function?
Can you put in the
Why
floor?
is it upside down?
Here you go. You can you're upside down.
Hey!
I literally cannot
Okay,
read.
turn it
I have
right
to
side up.
flip my monitor
Yeah.
upside down. Oh,
Well
second
done,
place.
Haku, Derek, Liliana. Excellent job, all three of you. And thank you
Why was
everybody
Haku
for
down?
participating. Guys, this meeting is about to close. So those of you who who's had the actual class, feel free to leave and enjoy your week. Whoever joined late, feel free to stay behind and I will go through the class again with you, but we will have to go into a new meeting. Yes, this class is every week now. I will send a reminder in the WeChat. Okay, bye guys, everyone.
Bye.
Bye.
Yeah,
If you
next
joined
week.
late, feel free to rejoin. I'll set up